More than 50 years ago, on December 7, 1972, the last of the Apollo missions began a launch countdown that would result in the last human footsteps on the moon for the foreseeable future. Secured atop the mighty Saturn V, 3 astronauts began their journey at 12:33 a.m. in the first and only Apollo night launch. On board were mission commander Gene Cernan, one of only 3 astronauts to make 2 lunar voyages, lunar module pilot Jack Schmitt, the only geologist to explore the lunar surface, and command module pilot Ronald E. Evans, the current record holder for time spent in lunar orbit at over 147 hours. After setting out on the translunar coast, NASA and the crew set their sights on the moon and the southeast edge of the Sea of Serenity. Their destination was a valley even grander than the Grand Canyon that spanned 4.5 miles across, surrounded by towering massifs over 6,000 feet tall, called the Taurus Littrow Valley. Taurus Littrow is a rare gem of a landing site that offers unique access to a variety of geologic features like highland and mare terrain, unearthed boulders, impact ejecta, landslides, a lobate scarp, and possible volcanic vent. A destination choice guided by the hope of encountering proof of young volcanic activity and other key discoveries. As promising as it was, landing in the valley was a dangerous task. In addition to a small landing area tucked deep between high mountains, the valley had a cratered floor and scattered boulders. The team safely maneuvered the lunar module down to the surface on December 11th, marked here with the remaining Challenger landing stage. The Challenger LM was similar to previous Apollo lunar modules, but it contained the most advanced suits, gear, experiments, and procedures of all the missions. Looking southeast of the LM, the heavily used lunar roving vehicle remains at its final parked location. And to the west, the Apollo Lunar Surface Experiments Package, or ALSEP, and corresponding hardware left behind by the astronauts. The ALSEP featured a series of new, exciting experiments and refined equipment from previous investigations. This included the Lunar Atmospheric Composition Experiment, which tracked the composition of the weak atmosphere on the moon, the Lunar Surface Gravimeter, a seismometer NASA hoped would detect free oscillations of the moon compared to those of Earth, and the Heat Flow Experiment, used to measure thermal properties of the surface, deployed successfully after experiencing technical difficulties on both Apollo 15 and 16. The first extravehicular activity, or EVA, began as astronauts Gene Cernan and Jack Schmitt climbed out of the LM and onto the lunar surface, unpacked the lunar rover, set up the ALSEP, and grappled with the deep drill core sample, a tough recovery that would later allow scientists to study the composition of solar wind over time.
Boy, that sure was drilling in hard stuff because it took a lot to get it off.
After the initial tasks were complete, the team drove the LRV southeast to a small crater on the fringes of Steno Crater. The astronauts sampled subsurface materials, collected a gravimeter reading, and deployed explosive charges for the lunar seismic profiling experiment. Though short on time, the team completed their tasks and took a moment for a gorgeous panorama of the area. During the first few sampling tasks, it became clear that having a geologist on the team was invaluable. Astronaut scientist Jack Schmitt analyzed samples on the go, removing the necessity for usual, lengthy communications with Houston to help determine a sample's geologic significance.
Very good. Oh, look at the dark minerals in there. Are those dark, black? Yeah, they may be ilmenite or fresh piercing. Well, look at it.
On their return trip, Cernan and Schmitt took a moment to deploy a seismic charge, get oriented with their surroundings, and adjust to navigating the lunar surface. After waking up, Cernan and Schmitt set out on the longest traverse across the moon in both distance and time made by astronauts, nearly doubling the prior distance records from Apollo 15 and 16. The team wanted to focus on sampling boulders from what appeared to be a landslide near the South Massif, about 7 kilometers southwest of the LM. The pace was swift and the terrain was complex. Cernan had to maneuver around the craters and potholes that riddled their path. At Station 2, on the edge of Nansen Crater by the South Massif, the team sampled 3 boulders, one from a nearby landslide. The decision to sample this location paid off. The team collected the oldest lunar sample ever, at approximately 4.5 billion years old. The sampled boulders have been reconstructed with photogrammetry, using the original handheld images taken by Cernan and Schmidt. Look closely and the original sample locations can be seen, labeled here with arrows. Next, the team made their way toward Laura Crater and Station 3, with a quick stop to collect gravimeter data and take rake samples. Located near Lee Lincoln Scarp, Station 3 was the only Apollo sampling spot near a lobate scarp. A core sample collected here remained carefully stored at Johnson Space Center until it was opened for the first time last spring. The team moved on to Station 4, on the rim of Shorty Crater, searching for evidence of young volcanism. Schmidt quickly noticed orangish color in the regolith as he approached the crater rim.
There is orange soil. Well, don't move it till I see it. It's all over.
The orange samples were later identified to be formed of molten drops from a lunar volcanic eruption 3.5 billion years ago. Some of the most important samples ever returned to Earth, proving that the Taurus Littrow Valley was the right place to search for volcanic material. The last station along EVA-2 was within the boulder fields of Camelot Crater. Here, Cernan and Schmidt collected boulder samples that helped scientists reconstruct the orientation of the ancient lunar magnetic field. Here is a beautiful panorama of the boulder field taken by the astronauts. On December 13, 1972, the last human exploration of the moon for at least 50 years took place. Cernan and Schmidt set out in the LRV, focused on collecting samples from large boulders at the base of the North Massif and the sculptured hills east of the landing site. Cernan and Schmidt drove to Turning Point Rock, then across and up the slope to Station 6 to sample Tracy's Rock, a huge split boulder that rolled down the North Massif and settled on the south slope. The boulder contained fragments of bluish-gray breccia and impact melt. Many chunks of bedrock and breccia from the surrounding areas rolled down the steep hills of Taurus Littrow Valley. By collecting multiple samples from key features along their traverse, the astronauts would help uncover the geologic history of the larger region. Cernan and Schmidt continued to explore along the base of the North Massif, collecting more samples before heading to the base of the sculptured hills for another gravimeter reading and further sampling. They collected a small boulder that was later identified as a platonic rock about 4.34 billion years old from deep within the early crust. The team's final station was Van Serg Crater. While there, the astronauts took some time to dig a trench to collect samples of the subsurface material. They deployed the last explosive charge from the seismic profiling experiment and began to drive back toward the lunar module. While passing Sherlock Crater on the return trip, Cernan and Schmidt beat the previous Apollo 16 lunar speed record by reaching a speed of 18 kilometers per hour, all while carrying more sample mass than any other Apollo mission EVA. Once back at the LM, Jack Schmidt had the honor of throwing a hammer, a task he claimed was a time-old geologist tradition.
Look at that! Look at that! Look at that! Beautiful. Looked like it was going a million miles, but it really didn't.
The throw commemorated a plethora of records broken during the mission. Records achieved through advanced equipment, exceptional training, and experience acquired over the past decade of lunar exploration. Prepared to meet back up with Evans and head home, Cernan and Schmidt executed the final Apollo lunar blastoff. The LRV camera, which was being controlled remotely from Earth, captured the final moments of human exploration on the moon. Apollo 17 was the end of an era of exploration that resulted in astounding scientific discoveries and technological advancements that helped provide insights into our understanding of the formation of our solar system.
This valley of history has seen mankind complete its first evolutionary steps into the universe, leaving the planet Earth and going forward into the universe. I think no more significant contribution has Apollo made to history. It's not often that you can foretell history, but I think we can in this case. And I think everybody ought to feel very proud of that fact.